All right, let's talk about scientific research. We hear that phrase all the time, right? But what's really driving it? What's the point? Well, it turns out there are two fundamental paths any study can take, and today we're going to break them down.
So let's just boil it all down to one big question. When a scientist starts a project, what are they really trying to do? Are they on a quest to just know more stuff? Or are they on a mission to fix a specific real-world problem? The answer to that question is the key to everything we're about to cover.
Okay, here's our game plan. First, we'll get a solid handle on what scientific research even is. Then, we'll explore those two big paths it can take. After that, we'll zoom in on each one, basic research and applied research. And finally, we'll put them head-to-head to see how they really stack up. First up, what is scientific research? The foundation of knowing. Right. Before we can talk about the different flavors of research, we've got to agree on the basic ingredients. What actually makes a piece of work scientific? Here's the textbook definition, but let's unpack that. The key words here are systematic and disciplined. This isn't just, casually looking things up online. It's a structured, careful process with rules. You have a method, you stick to it, and the entire goal is to genuinely increase our understanding of how things work. So, these are kind of the ground rules. It has to be a systematic process that uses disciplined methods. It's all about pushing our understanding forward. And, this is a big one, it demands precision and accuracy. And it tries its absolute best to be unbiased. It's a really controlled, careful way of learning. Next section, the two paths of research, or exploring the why behind the work. Okay, so we've got the what down. Now we get to the why. Because the motivation, the purpose behind a study, is what splits research right down the middle into two main roads.
Think of it like this. On one hand, you've got the pure explorer. They're on a quest for knowledge, driven by curiosity just to see what's over the next hill. On the other hand, you've got the engineer. They're on a mission for solutions. They have a specific problem, like how to build a stronger bridge, and they're laser-focused on solving it.
And of course, these two paths have names. That quest for knowledge is what we call basic research. And that mission for solutions, that's applied research. It's that simple. Now let's dig into what each of those really looks like. Let's start with basic research, the quest for fundamental knowledge. You can think of this as research driven by that fundamental human itch, the simple question, I wonder why that happens. It's about knowing for the sake of knowing. So the formal definition says it's all about expanding fundamental knowledge. And that word fundamental is everything here. The goal isn't to invent a new gadget tomorrow. The goal is to build a deeper, more complete understanding of the basic principles of how things work, with the belief that this knowledge will be valuable down the line. So what are these researchers actually doing? Well, lots of things. They're trying to expand the map of human knowledge. They're stress testing big theories to see if they hold up. They're trying to make sense of how society is changing. Sometimes they're even building better tools for other scientists to use. It's all foundational work. Let's make this concrete. Imagine a study looking into the technical needs of university professors who are teaching online. Now, the point isn't to sell a specific piece of software or fix one college's Wi-Fi. It's about understanding the broader phenomenon, the fundamental challenges of online education, which can then inform countless future solutions. But here's the catch, and it's a big one. As the quote says, the knowledge you get from basic research often does not offer short-term practical solutions. There's no immediate payoff, you can't always see the application right away. It's all about playing the long game, and that requires a whole lot of patience. So, let's flip the coin and talk about applied research, the mission to solve problems. If basic research asks, what if, applied research asks, okay, so what do we do about this right now? This is science with a clear, practical mission. The definition here is really direct. It's about understanding a problem in order to solve it. The keyword is solving. The final product isn't just a paper for other academics to read. It's a real-world solution, a recommendation, something you can actually use. In other words, this research is totally purpose-driven and pragmatic. It has a specific job to do, whether that's improving a company's workflow, evaluating a new government policy, or developing an effective public health program. And its goals totally reflect that. We're talking about solving immediate problems, making concrete recommendations, assessing what a community actually needs, checking if old policies are still working, and pushing for real, tangible change. It is all about action. A perfect example of this is a study that tests whether a new intervention program for teenage obesity actually works. The question is super direct. Does this thing we made do the job? And the findings are meant to be applied immediately by doctors and public health officials to improve kids' health. Okay, we've met the two contenders. Now it's time for the main event. Let's get to the showdown, a side-by-side comparison to really nail down the differences between basic and applied research. This chart really lays it all out. Look at the purpose, expand knowledge versus solve a problem. How about the outcome? Basic research gives us theories and ideas, while applied research gives us actual solutions and policy changes. And this one's really key, the audience. Basic research is written for other scientists, so the language is super technical. But applied research, it has to be understood by the practitioners and policymakers on the ground who will actually use it. Now, here's a really important point. We've been talking about these two as if they're polar opposites, but in reality, it's more of a spectrum. It's a continuum. A lot of research actually lives somewhere in the middle. A study can be mostly basic, but still have some practical implications, and vice versa. They're not mutually exclusive. Okay, last section. So why does any of this matter? What's the big picture takeaway? What's the so what? Well, understanding this difference is kind of like having a secret decoder ring for science. It helps you critically evaluate the studies you read about in the news. But more importantly, it helps you appreciate how major breakthroughs happen. They don't just appear out of thin air. Almost every practical solution we have today is built on a massive foundation of decades of basic fundamental research. You simply can't have one without the other. And that leaves us with one last thing to think about. When you look at the biggest challenges facing the world today, climate change, global health, you name it, where should we put our focus? Do we need more fundamental knowledge from basic research, or do we need more immediate practical solutions from applied research? It's a really tough balance to strike, and there's no easy answer.